All right, so 5.3 is called properties of logs. So we're going to go a little bit further into logs and manipulate them a little bit. And then, like I said, on 5.4, we're actually going to solve equations involving log with what we're about to do. So the first thing we're going to talk about is something called change of base. So the change of base in logs is what allows us to find the log with any base. In your calculator, you have two log buttons, technically. You have log, right, which is really the same thing as log base what? 10. You have another log because you have ln of e. So those buttons on your calculator are obviously what you can use. Now what happens if it's not log base 10 or log base e? And that's what change of base allows you to do. So the change of base says that if I have the log with any base, I can rewrite it as log of the larger, and by larger I mean physical size, not value, the larger number, over log of the base. Think base would be on the bottom, like a basement, right? It would go to the bottom. So whatever's here will be the one that goes to the bottom of the fraction. So if I had something like log base 3 of 23, I would rewrite that as log base 10 of 23 over log base 10 of 3, or log base e, so ln of 23 over ln of 3. And then you let the calculator do the work for you. So when you type that in, you've got to be careful, and so you can practice it. And you have to close the parentheses after the log. So if I do ln of 23, I have to close the parentheses on a graphing utility. And then do ln of 3. Hit enter, and you should get that 2.8404983. Yes. If I used like your iPhone calculator, then you have to do it in the reverse order. You'd have to do 23, and then you'd hit ln or log, and then divided by 3 ln or log, and then at the end equals. So this is why it's so important to be practicing with the calculator you're going to use next week, because they're going to be different, okay? If you want to practice with the scientific and a graphing, that's fine, but you want to make sure that you know how to use one or the other. Now, I'd get the same exact answer if I do log 23 divided by log 3. So those two are interchangeable. You could use any.
On my calculator, when I type that in, it puts the parentheses after.
Log.
Log or ln.
It should do log and then like this, right?
Yes.
And then 23.
Oh.
And then you have to close the parentheses. Divided by log, it'll open the parentheses 3, and then you could just hit enter. You don't have to close the parentheses on that one. But you have to close the parentheses, otherwise it's finding the log of the log.
Mm-hmm.
Yeah, you'll get the wrong answer. So the first example say, rewrite as a ratio of common or natural logs, and then evaluate, and round to 4 decimal places. So the first thing I'm going to do is rewrite it. The common log means which one? Log base 10. The natural log means what? ln, good, or log base e. So it says or, you could write either one. So I could do log of 25 over log of 4, or I could do ln 25 over ln 4, and then literally type that in the calculator. Log 25 divided by log 4, and I get 2.32192. So it would round to that.
They're the same thing.
Yep. God bless you.
Thank you.
They're technically not the same thing, but the ratios are the same things.
Because you're dividing either by log base 10 or log base e. So logs cancel out.
They don't really cancel out. So it's not like I'm doing this and doing that. That's a different answer, right? They don't cancel out. They just allow it to happen.
How much do you round it to on like a test?
It'll tell you. So this one says for the test, it's going to depend. It might be nearest 10th, it might be 100th, it might be 4. You just got to pay attention to what it is. Okay, so now number 2, how could I rewrite that? Good. Log 12. Hello. Or it could be ln 12 over ln 2. 3.58496. So the 9, the 6 rounds up the 9, rounds up the 4. So 3.5850. And you technically don't need that 0. So if that last digit isn't, it's not a significant number, you don't need it. Questions on these? So again, that's called change of base. You're going to hear me say that later, but that's what that's called. Okay, so then there's 3 major properties of logs that allow us to do what we call expand or condense logs. The product property says that if I'm finding log of the same base of a product, so 2 numbers being multiplied together, then I can actually expand this out into 2 separate logs by changing that product to addition. So the multiplication here splits as addition. Okay, the next one is the quotient property. And this says if I'm dividing logs with the same base, so log of A, whatever that base is, doesn't matter, U over V, so that's my division. When I split this, it becomes subtraction. So division becomes subtraction. Wait for it. And then the last one's called the power property, and this is when a number is raised to an exponent. So when you're raising the power, or any kind of base, any kind of number or value to an exponent, that exponent gets bumped to the front of your log and we multiply it. So it goes from an exponent to a multiplication. So think about where these come from, these rules come from, and they come from the rules on exponential functions. So let's go back to this one, and if it's multiplication, okay? So if I'm multiplying, let's say I have x to the second times x to the third, what do I normally do with those exponents? Add them. So that's why multiplying results in adding. If I had x to the 7th over x to the 5th, so I'm dividing, what do I normally do with those exponents? Subtract them. So this would be x to the 2nd. So that's why division becomes subtraction. And then if I was to raise x to the 2nd to the 3rd power, what do I normally do with those exponents? Multiply them. So that becomes x to the 6th. So because logs are just another way of writing an exponential expression, that's why those properties apply the way that they do. So you're going to see these in 2 ways. One is like what you're seeing right now. This would be called expanding. We took something that had one single log and we spread it out, so we expanded it into 2 logs. That's the expansion part. You'll also see it gone back the other direction. So you'll see it start on this side and it will say condense, and you want to condense it down to 1 log. So if your equation literally only has 1 log, you're going to expand it. But if your equation has multiple logs, you're going to condense it. And it will say sometimes literally expand or condense, or it will say expand or condense, and you've got to figure out which way to go. And when we get to equations in 5.4, you're going to figure out which way to go. So just think that if there's 1 log, you're going to break it apart, and if there's multiple logs, you're going to put it together. All right. So the first one just says find the exact value of log base 5 of the cube root of 5 equals x. So what can I do here? Okay, so log base 5 of 5 to the 1/3 equals x. So now think about this in 2 ways, because there's a lot of different ways to do logs. What's one way to simplify this?
Just cross it out.
Just third for the log.
Good. Okay, so perfect. You both said the same things. Okay, not the same things. You both said the right things. So Juliana said I could just cross these out and keep my exponent, so 1/3 would equal x. That's correct. And then Ethan said because this is a power, I could push it to the front. So I'd get 1/3 log base 5 of 5 equals x. And then what is log base 5 of 5? It cancels to give you the exponent, right, which would be 1. And then I'd get 1/3 equals x. So it doesn't matter which way your brain sees it, as long as it sees it one of those ways. Okay? So all the things we've already done with logs can be now carried into the properties.
But we didn't have to do any of the separating or anything?
No, so it didn't say, if it had said expand and then simplify, then you'd bump the 1/3 to the front. Yep. Like this one, it says expand. So this one we're not going to solve, we're just going to expand it. So what's happening here? What is this whole thing? Is that a product, a quotient, or a power? It's got a power and a product. So the first thing I'm going to do is split it with the product. So I'm going to go log base 4 of 5. When I expand, product becomes what? Addition. So plus log base 4 of x to the third plus log base 4y. Once you break it apart, you should only have one number or variable with each base. But there's still that power, right? So what happens with the x to the third? 3 moves to the front. So this becomes log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. And sometimes when we expand like that, we're able to simplify things. So you want to look back at these individual logs and see if there's something you can simplify without using change of base. So like this log base 4 of 5, if that was like log base 4 of 4, I would simplify that. But I don't need to do, I'm not doing change of base. Change of base means you involve a calculator, which means you're rounding, which makes it less accurate. Okay, now look at 5. So this bar, right, this division bar becomes subtraction. ln square root 3x minus 5 minus ln of 7. Am I done? No. What's the square root? 1/2. So this becomes ln 3x minus 5 to the 1/2 minus ln 7. And then what? Good. That half goes pushed to the front. 1/2 ln 3x minus 5 minus ln 7.
Why can't you have the exponent?
Because it's not as expanded as it can get. So if it has an exponent, it's not all the way expanded. It's kind of like simplified. You'd have to keep going. So because it's 3x minus 5, I don't mess with that product. Like 3x can't be broken off from minus 5. If it was just 3x, now I'd get sum, and it'd be 1/2 ln of 3 plus 1/2 ln of x. But because that minus 5 is there, when we expand, we can't expand with minus. We make it minus, but we don't expand with minus. So this answer stays the way that it is. Yep.
Not just about this problem, but when we have the square roots, I get confused on how to what to change them into.
So anytime you see square root, it's a half. Because a square means there's an index. That little number on the front is actually a 2. You don't see it on a square root because it's implied. If it was a cube root, now it's 1/3. If it was a fourth root, 1/4. So whatever's on the front, the little index is what it's called, matches the bottom of my fraction. If it was like 2/3, right, the 3 would be at the front, so the 3 would be, and then the squared. Yep. You're welcome. All right, number 6, expand log base 3 of 4x squared divided by the square root of y. So the subtraction happens with this guy. So log base 3, and be careful, don't lose the base, okay? 4x squared minus log base 3 square root y.
Do you know the 2 or the x squared?
So here's what's tricky. This is not in the parentheses. So the 2 doesn't go to both. So before I move that 2, I have to break apart this product.
So log base 3 with the 4, and then log base 3x squared.
Good. So log base 3 of 4 plus log base 3x squared minus log base 3. How about that square root y? That becomes what? Y to the 1/2. So my products are all, and my quotients are all spread out, but I still have exponents, right? So all of those exponents, nothing on the front. That one stays the way that it is. But this squared has to get bumped to the front, and this 1/2 has to get bumped to the front.
If it had parentheses on the 4x, you would distribute it?
No, well, you could, or you would, here, hang on, let me write it this way. Oh, because I already forgot the 2. I'll show you. 2 log base 3x minus 1/2 log base 3y. So the question is, what if that was log base 3 4x squared like this, which is a good question.
Yes.
So you have 2 choices. 1, distribute the squared to both. 4 squared x squared. Then show them as a product of properties. The product, log base 3x squared. Then the 2's go to the front. So if your brain says, I'm supposed to distribute that, then that's the way that works. If your brain says, I'm supposed to push this to the front, that works too. You just have to remember that when I split these now, both get the 2. So this would be like 2 log base 3 of 4 plus log base 3 of x. And then both these get the 2. So again, multiple ways at looking at the same thing. You kind of have to like find your rhythm and find what you would do. Questions on those? Okay, now we go back the other way. So now we're condensing. How do I know the difference? 1, directions literally say a different word. But eventually it's not. It's going to say simplify. It'll say expand or condense. But what do you notice about all of these questions that were different from the last ones?
There's more than one log.
There's more than one log. If you see the word log or ln twice, or 3 times or however many times, you're going to have to condense it down, okay? And they're not on the other side of the equal sign. Like we've done one-to-one properties where they're on other sides of the equal sign. These aren't like that, right? Okay, so let's look at 7. Walk me through it. What's one thing we could do?
Log x squared. No, 1/2.
Good. So the 1/2 bumps back. Log of x to the 1/2, which is the same thing as what?
Log base 10, base 10, yeah. And
The square root of
Square root of x.
Oh.
Good. Yeah. Then take the 3 to the exponent on the other one. Log base 10x plus 1 to the 3rd. Are they both log base 10s?
Yes.
If they weren't, you couldn't do anything. But the fact that they're both log base 10s means I can go one step further. This is addition, which means it would become what? Multiplication. So condense means get it to 1 log.
So if there's ever a fraction, you have to make it a square root.
Yep. And if it was a 3rd, it'd be a cube root. And if it was a 4th, it'd be a 4th root. Yeah. You can't have anything on the front. And then when you bump it to the exponent, you can't have an exponent. That's a fraction. Yep. Okay. 8. What's happening with the 2 on the front? This. Good. This becomes the exponent. So ln of x plus 2 squared. And then the subtraction becomes what?
Division.
Good. I don't think you need the parentheses on WebAssign. I think as long as you put it in that fraction form, it's fine. Let me check. Just keep in mind, if I was to like plug this into a graphing utility, I'd have to make sure that that's grouped, like the numerator and the denominator separately. You're not graphing these now, but like if you were to type that in to check something, you'd have to watch your parentheses. All right, now what?
That's what I had, like,
1/3 is both of
1/3 goes to both of them. So I would distribute, right? So I can rewrite it as 1/3 log base 2 of x plus 1/3 log base 2 of x plus 1. Or, and again, you'll get better at these, right? Like just like our mental math on the beginning. I could actually bring that straight to the exponents of each, okay? So now these become the exponents. Log base 2 of x to the 1/3 plus log base 2 of x plus 1 to the 1/3.
Why do they become two?
Then what?
A cube root.
That becomes a cube root. Then what? It's multiplication. Can I multiply a cube root times a cube root into one cube root? Yeah. So if it was a square root and a square root, right? If it was like the square root of 8 and the square root of 2, I can combine that together to be square root 16. It's the same thing here. So I can rewrite this as 1 cube root. Log base 2 cube root x times x plus 1. Oops. And you can leave it like that. Or if your brain says distribute that, you could also distribute it. Yep. So it'd be,
You can leave it like
you can leave it like that, yeah. You don't have to do the extra step. Save yourself a little bit of time. But those are both right. All right, last one. Now what?
Distribute the
just
two.
distribute it.
Okay, let me show you this, because what else we could do is make it like this, because you could do this either way, and we didn't do it with the other one, but this whole thing could be squared, right? This could get bumped to the back of the squared, right? Then I could work with inside first. So this is just an option. You could distribute it, right? Or you could do this. I'll work both ways, right? So actually, let's do the distribute first, and then I'll come back to this. So distribute it here. And I get 2 log x plus 3 minus 4 log x minus 2. So let's work the way that you guys were talking first. Now what?
Put it to square root.
Square that. So it's log x plus 3 squared minus log x minus 2 to the 4th. And then minus becomes division. Okay, so if I had, if I had done it this way, if I had put this squared behind it, then I can work inside the parentheses first. Log x plus 3 minus this 2 comes here now. I swear I charged this last time.